Welcome back, everyone. Last time we talked about the parent graphs for all the trig functions. Today we're going to start the transformations. You really need to know the parent graphs for the trig functions, especially the important points, like the maxes and the mins and the x-intercepts and the asymptotes. There's a lot of places to make mistakes here because we're going to move those points around. Okay, so if I make a mistake, I'm just going to erase it and keep going. Let's start off with the simple ones. Let's go cosine of x plus 2, or 2 plus cosine x. Now from algebra 2, you know that means it goes up 2. So I'm going to take every point here that's important on the cosine graph, and I'm going to move it up 2. So for example, this used to be 0, 1. If I add 2 to it, it's now 0, 3. This was the point, pi over 2, 0. Now it's pi over 2, 2. And so on. So all I'm going to do is I'm going to make a list of the important points, and I'm going to add 2 to the y value to make it go up 2. They didn't draw this graph in, but negative cosine x, this is a flip or a reflection over the x-axis. So we're just going to draw that in really quickly. If I reflect 0, 1, I'm going to be at 0, -1. If I reflect pi over 2, 0, I'm still going to be at pi over 2, 0. This is pi, -1, which will flip up to pi, +1. And you can see the shape is just a reflection of the original one. So those are the easy ones, up, down, and flip. What does the number in front of the sine of the cosine do? Well, in algebra 2, we call that a shrink or a stretch. This year, we refer to it more specifically as a vertical shrink or a vertical shrink or a vertical stretch. So, all it's really doing is telling you that instead of bouncing between 1 and -1 like it usually does, now it might bounce between 2 and -2, or 3 and -3, or 1/2 and -1/2. We call that thing the amplitude. The amplitude tells you how far up and down these things go. Amplitude. So, for example, y equals 3 sine x has an amplitude of 3. Y equals 1/2 sine of x has an amplitude of 1/2. What is the amplitude for normal sine without anything in front? Well, there is a number in front. It's got an amplitude of 1. What about the letters with x? Well, we didn't do these in algebra 2, but in math analysis earlier in the year, we referred to these as horizontal shrinks or stretches, or horizontal stretch and compression. And it's opposite of the value that you think. So a 2 here isn't a horizontal stretch, it's a horizontal compression by 1/2. A 1/3 would be a horizontal stretch by 3. This shrinks the period. So I'm going to take whatever this number is and put it underneath whatever the period is. In this case, the period's 2 pi, because for sine and cosine, the period is 2 pi. If we were talking about tangent, I would put pi there. That changes the period. We're going to graph it differently, but if they ever ask what's the period, that's how you do it. So, in short, this tells you the amplitude, and 2 pi over k tells you the period. So if I had y equals sine of 2x, what's the period of that guy? Well, it's 2 pi over 2. So now the period is pi. In other words, I took what used to take 2 pi to happen, and now I'm going to shrink it down to happening in only pi. I'm compressing it horizontally by a factor of 2. Find the amplitude and period. Okay, the amplitudes are easy. The amplitude's 4. The amplitude is still 2 here. It's just flipped over the x-axis. It doesn't change the amplitude, but it just changes the direction it goes. Instead of going that way, it'll go this way. So the period's a little bit tougher. The period takes a little bit of arithmetic. So it's the period that it starts with divided by whatever the k value is. So that one's easy. Here, I have 2 pi divided by 1/2. Dividing by 1/2 is the same thing as multiplying by 2, so it's 4 pi. So this graph, instead of repeating every 2 pi, gets stretched out so it doesn't repeat until you get all the way out to 4 pi. Okay? What about if we add or subtract with the x? Well, this is just going to move it left and right, opposite of the side. We call that the phase shift, a horizontal shift or a phase shift. Notice that I've got to factor the k out of this problem. Okay, so find the amplitude, the period, and the horizontal shift or the phase shift. I've seen it called both, so I need you to get used to it. Of this graph and complete one period, graph one period. Well, naming everything is easy. 3 is the period, 3 is the amplitude. The period is 2 pi over this number, so the period is pi. And it went right, pi over 4. So the explanations are easy. The graphs are a little bit tougher. So, let's try to graph this. And I'm only going to graph one period, so I'm only going to graph the right side. The most important thing here is to know that it's a sine graph. So sine goes here at 0, 0. And then here, this is the point pi over 2, comma 1. Here, this is the point pi, comma 0. Down here, 3 pi over 2, comma negative 1. Then back up here, 2 pi, comma 0. And here's one period of the sine graph badly drawn. So now let's do the transformations. We're going to stretch it by 3, we're going to horizontally shrink it by 2, and we're going to go right pi over 4. But instead of doing it on the graph, I'm going to kind of make a little table. So what are my important points? Well, they were 0, 0. They were pi over 2, comma 1. They were pi, comma 0. They were 3 pi over 2, comma negative 1. And they were 2 pi, comma 0. That are the 5 points that really make up one period, and then I just connect the dots. So let's do some transformations. The first one is a vertical stretch by 3. A vertical stretch just takes the y value and makes it bigger. So I'm not going to change the x value, but I'm going to multiply the y value by 3. Well, if I multiply 0 by 3, I'm still at 0. But if I multiply this y value by 3, I'm way up at 3. If I multiply this y value by 3, I'm still at 0. I'm now down to negative 3, and I'm still at 0. Oops. Like I said, guys, there's a lot of places to make mistakes here, so be careful. So that's the vertical stretch by 3. The next thing is going to be the horizontal compression by 1/2. In other words, now I'm going to take every x value for the horizontal and I'm going to compress it or divide it by 2. I'm going to make it 1/2 as big. You can either multiply by 1/2 or divide by 2. It's the same thing. But if I multiply 0 by 1/2, it's still 0. If I multiply pi over 4 times 1/2, make it half as big, now it's pi over 4 instead of pi over 2, the y value stays the same. Multiply this by 1/2 and I'll get pi over 2, comma 0. 3 pi over 4, comma negative 3, and then just plain pi, comma 0. I took all the x values, because I'm doing a horizontal compression, so I'm looking at the x values, and I compressed them by 1/2, so I multiplied them by 1/2. And lastly, right 4, pi over 4. Okay? Left and right, what's that going to affect? It's going to affect the x values. So I'm just going to add pi over 4 to all of my x values. So this becomes pi over 4, comma 0. Pi over 4 plus pi over 4 is 2 pi over 4, or pi over 2, comma 3. Pi over 2 plus pi over 4 is 3 pi over 4, comma 0. 3 pi over 4 plus 1 pi over 4 is 4 pi over 4, which is just plain pi, comma negative 3. And then pi plus pi over 4 is 5 pi over 4, comma 0. Now I can graph these 5 points, and once I have them on the graph, I'll just connect the dots to make the same shape. This shape isn't going to change. So let's go back to this graph and let's try the best job we can. This was pi over 2, so in between must be pi over 4. The next point is pi over 2 comma 3. Pi over 2 comma 3, I'm sorry I do this really badly, but it's going to be way up here. Pi over 2 comma 3. So my graph's going way up here. The next point is 3 pi over 4 comma 0. Well, 3 pi over 4 is right between pi over 2 and pi, so it's right here. 3 pi over 4 comma 0. Where's my next point? Pi comma negative 3. So pi comma negative 3, way down here. And where's my last point? 5 pi over 4 comma 0. Well, 5 pi over 4 is just between pi and 3 pi over 2, so right there. It looks really complicated, but if you take the time to map out the points and then do each transformation by itself, then you can be done. What if I added one more transformation? If I added let's say a plus 2 right here, how would that change the graph? Well, I would do everything I've just done, and now I would take all of my y values and I would add 2 to them. So just do them in the order you see them. Do the vertical, shrink or stretch to make the amplitude, change your period, multiply the x values by 1 over whatever this is, and then move it left or right, and then up and down. Remember, list the points. It makes life a lot easier.